Hi, I'm Yeli. I go by Yeli. I'm going to go straight to it, so I want to pose a question, which is, what is the male equivalent of a ball buster? And I'm not going to give you that much time to think about it, because there is none. There is no word for a demanding man who destroys women's confidence, but there are plenty of words for demanding women who destroy men's confidence. So this was the question I was thinking about when I made the claim that language is sexist, and those biases that are inherent in language affect us in ways we can't even imagine. For example, they make their way into things that are supposed to be objective. So in the Turkish language, they have the gender-neutral pronoun o, which covers he, she, and it. So when you're translating from Turkish to English, Google Translate has to pick whichever gendered pronoun to use. So this is a poem written by Google Translate on the topic of gender, and it's as a result of translating Turkish sentences to English sentences. So it's he is a soldier, she's a teacher, he's a doctor, he's a president, he's an entrepreneur, he's a dentist, he's a belly dancer. That one is kind of weird. But the algorithm is basing its translations on a huge corpus of human language data, so it's reflecting the bias that already exists. Obviously, Google Translate ended up fixing the problem because a lot of people were complaining about it, but obviously they can't fix language. In fact, a new research project from the World Bank linked gendered languages in countries all around the world to lower labor market participation rates for women and to more regressive gender norms. In practical terms, they said that it could account for up to 120 million women being out of the labor force. So thinking about how gendered language impacts us in ways we don't know, I decided I wanted to create something to explore it. That's what this talk is about, building a gender dictionary. So a gender dictionary is a library of gendered words in the English language. To be clear about what gendered words are, they are words for human beings that apply to a certain gender. So words like prince, princess, lady, gentleman. And the point of this, of building a gender dictionary, would be able to explore gendered language, to explore how sexism exists in language, to get ourselves to think about how the words we choose intentionally or unintentionally communicate things we might not mean to. For example, when navigating the site, users can learn what words have gender equivalents, so wife is the husband, and which words don't. So this is another word for a demanding woman, a demandress. They can also learn what words have undergone semantic derogation. So master and mistress started out as the same word, but over time, mistress has taken on more negative connotations than master hasn't. So even in just like thinking about it without the definition, you can tell that like master and mistress are different words now, even though they weren't supposed to be. So to build a gender dictionary, there were two things I had to do. One is get the data, and then two is get the gender equivalents. Before I started coding anything, I had to figure out what my criteria was. So what I would tell the computer a gendered word was. So that was any word with any of these terms in their definition. For example, archeress would be a gendered word because it's a female archer. So after I defined my criteria, I started looking for ways to get the data, which is my first stop was APIs. One of the first I found was called WordNik. WordNik has a feature called a reverse dictionary, so that means find all the terms in this dictionary with this term in the definition. So airwoman has the word woman in its definition, so it would be one of the reverse dictionary terms for woman. So I made a request to their API for the reverse dictionary of all those terms that I listed earlier, and then I got back a JSON. Well, this is what it looks like in code. This is Python. So they have an API, they have demos that teach you how to do it. For each request, I got back a response that looks like this. So this is JSON format, which means it's arranged as pairs of keys and values. So key is word, and the value is matron. However, when I looked at the response I got, so it says on the website they have 3,000 words, and I got 400 back, and I was like, what's up? So it's not uncommon. Many API services, they don't give you access to all of their data because you could just take all of their data and then make the API service yourself. So I understood why I wasn't getting everything back, but I was still like, so I had to find another way of getting the data, static data sets. I found a dictionary on GitHub. So I pulled that in with Python. Python has a JSON module that is built in, so you can use JSON load to load it in. And then we go back to the definition of a gendered word, which is a word that has one of these in its definition. So how do we check that? In Python, you can say if string in definition, so you can say if woman in definition, or female in definition, or lady in definition, or girl in definition, or mother in definition, but like this is very long, so we don't want to do that. Instead, we can use something called regular expressions. Regular expressions are a sequence of characters that define a search pattern. So my name is Omayeli, but people misspell it a lot. So I could create one regex pattern that matches my name and then all the misspellings for my name. So the regex pattern is on the left, and then all the matches are on the right. So I needed to make a regex pattern that would match all of these. So in regex, the pipe symbol is or, so this is saying match male or man or boy or husband, etc. But the issue with that is it isn't looking for whole words. So management is not man, so it shouldn't match that. It shouldn't match like boys with a $sign or a manhole or a manatee. So we can use word boundaries, and word boundaries allow you to match whole words. So now it's looking for whole words and not just parts of a word. But then I also want to match words like grandfather, so what can I do? Word characters. So word characters are ASCII characters, anything from A to Z or 0 to 9. So now it's matching the appropriate characters before the word father. So we wrap it in square brackets, which says this is a group, match any character that's within me, which is useful when we want to match something else. So we add a dash, so now it's matching G-father. And then we also want to match the whole thing, so not just the first letter before father. So this is saying match, the asterisk is saying match 0 or more of whatever is before me. So these are the final regex patterns. After I finalized the pattern, I went through the dictionary, and then if the definition contained one of these terms, and I added to an array. And then I did the same thing for the male terms at the bottom. So in Python, we use the RE module to handle regex expressions. So to do that, in line 3, we compile the pattern using the RE compiles method. And then in line 7, we can actually do the search. So we search the definition for the pattern that we're looking for. So when I added together the words from Wordnik and Webster, it came back to about 8,000 words, which is much more than the 400 that I started with. So I was pretty excited about that. I thought I could move on to getting the equivalents, but when I looked at the data, I saw some words that shouldn't have been there, like hobble skirt and pajama, and like skivvies, which sounds more like a disease than the name of men's underwear. So if we go back to the purpose of the gender dictionary, is to explore sexism in language, and to our definition of gendered words, we see that a clothing item would not fit. So I decided I added another step, which is filtering data. So I decided I would look for patterns in the incorrect words so I could figure out a way to remove them. One of the patterns I found is that in the incorrect words, the gender term was being used as the object of a preposition. What that means is, like, if you look at the definition for waterfall, it says an arrangement of a woman. For Peter, it's a common baptismal name for a man, so the gender term, woman or man, is coming after a preposition. So how would I remove words like these? First, I would break the string up into what I needed to look at, and I needed to look at everything before the gender term, which in this case is man. So I split the string where we find man, and we can use our regex to find where man is located. So I split the string. And then after I split it, I can use something called NLTK to get the parts of speech of the word. So NLTK stands for Natural Language Toolkit. It's used for processing the English language. To start a process, we first tokenize a string, which means you chop it up into different pieces. So you enter the text. This is a tokenizer demo. So you enter the text, and then it breaks it up into different parts. After we tokenize in line 5, so we import NLTK, we use its word tokenize method. So we tokenize in line 5, and then in line 8, we send it to the POS tagger, the part of speech tagger. So it gives us the parts of speech for every word in the string. In this case, we see that baptismal is an adjective, name is a noun, for is a preposition, man is a noun. And I know that because I looked it up. So we remove the A's and the ands, which is what's happening in line 4, and then we check we check what's before man, so in this case it's for, and then we see if that's a preposition. So if it's in, then we return false, and we say this is not a gendered word. So that's how I got rid of those. So I came down to about 4,000 words, which seemed more doable. And then the last thing I wanted to do was find gender opposites. I can do that using something called word2vec. So word2vec is an algorithm that transforms words to vectors. Back in 2013, a handful of researchers at Google set loose a neural net on a corpus of about 3 million words from Google News. So the goal of the neural net was to find patterns in the way words appear next to each other. So refrigerator, in their mapping, refrigerator is close to microwave, and it's far from grass. Grass is close to garden, it's close to hose, it's close to sprinkler. So the Google team discovered that it could represent these patterns between words using vectors in vector space. And then the relationships between words could be calculated using simple linear algebra. So these relationships are known as word embeddings. And they're based on the idea that a word is characterized by the company it keeps. So if, for example, if we gave the neural net this text, it would say that salt is more conceptually close to seasoning because it's used in the same context than it is to say chair, since chair is not used in the same context. And with that model, we can do really cool stuff like getting the similarity of words. So the similarity of woman and rectangle is about 0.1, which is pretty low. And then woman and wife is more than 0.8. Yeah. And then we can also do word analogies. So we can do woman is to queen as man is to king. So in Python, if you want to use the word2vec algorithm, you can do something. You can use the library called Gensim. So we load in the model, like you can actually download the model online. So we load in the model to Gensim in line 2. And then how you call the word analogy is how you're framing the analogy is like woman is to wife. So woman would be the positive term, and then word would be the wife, and then the negative term would be man. Okay, what? Yeah. And then if we get the result back, and then we can check if how strong the computer thinks the answer is, and if it's like maybe above a certain number, then we can say, okay, this is an equivalent. And so that's how I did it. I got the initial word set using APIs and static data sets. Then I filtered the data using regex and NLTK, and then I got the gender equivalent using word2vec. And I was able to create a data set of gendered words. And in summary, I guess the words that we have and don't have and how we use them in conversations matter. So like we risk reinforcing these biases that exist already in language if we don't think about the words we use and why. That's it. Thank you.